The move fee was never the main bill. Look at this clean graphic splitting one cloud migration into separate lines. In 2024, cloud giants waived some egress fees, but migration engineering, refactoring, testing, and dual running still made migrating expensive. If 2024 major hyperscalers, including Google Cloud and AWS, waive egress fees, why does moving workloads still cost so much? This is no tech. For years, the industry accepted a simple, compelling narrative about vendor lock-in. The narrative went like this: if you put massive amounts of enterprise data into a specific platform, the provider traps you by charging an exorbitant fee to transfer that data out to another environment. This fee became the ultimate villain of cloud economics. It was the red line item on the cost breakdown chart that everyone pointed to when explaining why enterprises could not easily switch providers or move back to their own hardware. And the logic seems completely sound. If it costs millions of dollars just to move your own files, logs, and customer records across the network, of course you stay put. Data gravity keeps you anchored to the vendor. If a vendor waives egress fees, leaving the cloud becomes cheap and easy. But when you look at the actual invoices and the engineering logs of teams who have executed these migrations, a very different reality emerges. The bill shrinks on paper, but the architecture still charges you to leave. Hold that thought. We need to unpack what leaving actually means in cloud architecture. Now move from the pricing page to the actual policy documents. In 2024, the landscape shifted. We watched as 2024 major hyperscalers, including Google Cloud, updated their terms. Specifically, AWS published policies to waive data transfer fees for customers leaving their platforms. Microsoft Azure made similar claims, though verifying their exact egress policy requires separate sourcing beyond standard public announcements. These announcements made headlines across the industry, and it seemed like the end of the trap. Across the board, the public message from the major providers was identical. We are not holding your data hostage. If you want to take your workloads to a competitor or back to a co-location facility, the network transfer is on us. At first glance, this looks like the end of vendor lock-in. The toll gate is open, and the red line item on the cost breakdown chart is gone. But read the fine print on that policy waiver page. The waiver is real, but it is not automatic, and it does not cover the labor. These waivers require a formal migration process. You cannot simply stream your data out for free on a Tuesday because you found a cheaper storage tier elsewhere. You have to declare your intent to leave, open a support ticket, get approval from the provider's team, and usually commit to closing the account entirely within a strict 60-day window. If you fail to complete the massive migration in that compressed time frame, you risk losing the waiver entirely and facing the very fees you tried to avoid. More importantly, the waiver only zeroes out the network bandwidth charge. It does nothing to address the actual work of moving a live, production enterprise system. Waived egress fees can reduce one part of the bill, but enterprises may still face application refactoring, migration planning, validation testing, and temporary dual running costs. To understand why that labor is so expensive, we have to look at how modern applications are actually built and where the real dependencies hide. Open the architecture schematic for a modern enterprise application. When a team builds in the cloud today, they rarely just rent virtual machines and install their own software. That defeats the entire purpose of the cloud. Instead, they rely on provider-specific managed services. They use the cloud provider's proprietary database engine, which automatically handles backups, scaling, and failover. They use the provider's identity and access management model to control which microservice is allowed to talk to which storage bucket. They use the provider's specific load balancers, observability tooling, and networking assumptions. This is where the real lock-in lives. It is not in the storage buckets. It is in the whiteboard arrows. Every one of those arrows represents a dependency. If you want to leave the platform, you cannot just copy your data and paste it onto a server in a co-location facility. You have to re-platform. If your application relies on a proprietary NoSQL database like DynamoDB, you cannot just drag and drop that database into a local data center. You have to rewrite the application code so it can talk to an open-source alternative like PostgreSQL or Cassandra. You have to translate your entire schema, remap your indexing strategy, and rewrite your query logic. This is not a simple automated export. It requires developers to manually untangle years of platform-specific optimizations that were designed to work perfectly, but only within that one provider's walled garden. You have to rebuild your entire security and identity model from scratch, because the old IAM roles, JSON policies, and virtual private cloud peering rules do not exist outside that specific vendor's ecosystem. You have to replace the managed message queues with self-hosted clusters. You have to replace the cloud-native monitoring tools with Prometheus and Grafana. Lock-in also comes from dependence on provider-specific managed services, IAM models, networking assumptions, observability tooling, and operational workflows. You are not just moving bytes, you are translating an entire operational model, and translation requires expensive, highly skilled engineering hours. That is why, when you look at the cost breakdown chart for a major exit, the refactoring slice dwarfs the original egress cost. Now, move from the architecture diagram to the operations floor. Look at the runbook checklist for a live migration. This is where the concept of two environments becomes a financial reality. You cannot simply turn off the old cloud on Friday and turn on the new servers on Monday. Enterprise systems require uptime. If you are processing financial transactions, routing global logistics, or managing healthcare records, a 12-hour maintenance window is unacceptable. To migrate safely, you have to build the new destination, secure it, and then run both systems simultaneously. You establish real-time replication between the old database and the new one, constantly monitoring for data drift that could corrupt user transactions. You route a small percentage of traffic to the new environment to validate that it works under load. You test the failover mechanisms. We actually broke down how that hardware procurement math works in our episode on cloud repatriation, bare metal economics. That one goes deeper into the capital expenditure of buying servers and leasing co-location space. It is worth a watch if you want the full breakdown on that side of the ledger. But here, we need to look at what that dual running phase actually costs in operational overhead. For weeks, or sometimes months, you are paying for two environments. You are paying your current cloud provider their full monthly fee, while simultaneously paying for the new hardware, the new co-location space, and the engineering team managing the transition. The hidden price of trust is that you often have to operate both systems before you can safely shut one off. You have to monitor replication lag. You have to build fallback plans in case the new network routing fails. You have to ensure that every single whiteboard arrow has been successfully repointed. Even with 2024 waivers from AWS published policies and Google Cloud, the hard costs move into engineering, testing, and dual running. The egress fee was just the cover charge. The real expense is keeping the lights on in two buildings at once. To see how this plays out in public, look at the co-location racks of companies that have actually pulled the plug. In recent years, the software company 37 Signals, makers of Basecamp and Hey, famously documented their move back to owned hardware. Stories like theirs are often cited in industry debates about whether repatriating workloads is the obvious financial choice. Discussions around these migrations usually focus heavily on the reduction in monthly infrastructure bills. But focusing only on infrastructure misses the human element. While 37 Signals could absorb this work using their existing team without increasing payroll, Most enterprises do not have that specific talent sitting idle. Ingredient to transition like this requires a highly skilled, specialized operations team, capable of managing bare metal, configuring hypervisors, handling BGP routing, and running open-source databases at scale. If they want to leave, they have to hire it or pay consultants to build it. They have to wait out hardware procurement lead times, sometimes stretching for months. They have to take on the operational risk of managing their own physical infrastructure, replacing failed drives, balancing power loads, and patching hypervisors at 2 in the morning. Look back at the policy waiver page. It waives the network transfer. It does not pay for those salaries. It does not pay for the consultants. It does not pay for the operational risk. And that brings us back to the delayed question. If the data can move for free, what keeps the bill so high? The cloud's real fee is the work of escape. When we put the pieces together, the architecture of lock-in becomes clear. Remember that policy waiver page we looked at earlier? It solves the easiest part of the problem. Provider-specific services turn code, not bytes, into the lock-in. The whiteboard arrows dictate how hard it will be to leave, because every managed service you adopt is a piece of infrastructure you will eventually have to rebuild yourself. And migration means replatforming, validating, and living in 2 worlds at once. The 2 environments guarantee that your costs will spike before they ever go down. The runbook checklist demands thousands of hours of highly skilled labor just to get back to where you started. The bill shrinks on paper, but the architecture still charges you to leave. Bring back that clean graphic, splitting one cloud migration into separate lines we opened with. By the end, the red egress line looks small beside the engineering hours, refactoring, testing, migration planning, and dual running needed to unwind provider-specific systems. The move fee was never the main bill. But this opens a harder question. What would it take to replace it without raising the failure budget? We track the invoices, the refactors, and the operational handoffs to show how cloud lock-in survives even when egress fees do not. Which constraint matters most here? Processor choice, failure budget, or replacement cost? See you on the next investigation.